You've been breathing your entire life without thinking about it. In, out, automatically, about 20,000 times a day. In space, you get about 15 seconds to remember how much you took that for granted. Explosive decompression. When your spacecraft suddenly loses pressure, a crack in the hull, a faulty seal, a micrometeorite the size of a grain of sand punching through at 17,500 miles per hour. If any of that happens, well, the air doesn't slowly leak out. It's ripped out violently, taking everything with it that isn't bolted down. Tools, food packets, and your breath. Mid-exhale, you don't explode, which is almost disappointing given the name. Your skin holds. You're basically a meat balloon that evolved at sea level. And while space really wants to turn your insides into your outsides, biology is surprisingly stubborn about staying contained. But what happens instead is worse, given that it's not as instant as simply popping. The air in your lungs expands. If you hold your breath, trying to keep what little oxygen you have left, your lungs rupture. If you exhale, you're speeding up the clock. 15 seconds of useful consciousness. That's what you get. Your blood doesn't boil in that cartoony way, but the moisture on your tongue does. Your saliva starts bubbling. Your eyes swell, but probably don't pop, though no one's volunteered to find out. You can't scream. There's no air to carry sound, just you, swelling, suffocating, surrounded by infinite nothing. And yes, that has, in fact, really happened to real people. June 30th, 1971, Soyuz 11. 3 Soviet cosmonauts were returning from the Salyut 1 space station. Georgy Dobrovolsky, Vladislav Volkov, Viktor Patsayev. They just set a record. 23 days in space, longer than anyone before them. Re-entry went perfectly. The capsule landed in Kazakhstan right on target. Recovery crews opened the hatch, expecting to find 3 tired, triumphant men. But they found 3 corpses with dark blue faces instead, with hemorrhages in their brains and ears. A ventilation valve had opened during descent, a mechanical failure. The cabin depressurized at 104 miles altitude. The cosmonauts had 40 seconds before losing consciousness. Enough time to understand what was happening, not enough time to fix it. They weren't wearing pressure suits. You know, the things astronauts wear to protect themselves from precisely this, because apparently they're too bulky. The capsule was cramped, so they flew in just flight suits to save space. That decision saved them about 30 pounds of weight, but it cost them everything else. The recovery team tried CPR for 2 hours anyway, which is optimism, bordering on delusion when someone's been dead for 20 minutes in a vacuum. All 3 were buried in the Kremlin Wall necropolis as heroes of the Soviet Union. So, yeah, 3 guys died because someone did the math and decided 30 pounds of fabric was heavier than the risk of depressurization. That's the bureaucratic calculation that kills people. Not malice, just cost-benefit analysis with human lives as a variable. And we did actually make pressure suits mandatory after Soyuz 11, which, yeah, is a great achievement and all, I know, except for the whole learning safety protocols by counting corpses approach to institutional reform. Rules written in blood as always. Sometimes we only learn by watching people die in ways that were entirely preventable. And as you'll learn in one of the upcoming cases, this decision was far more, to put it frankly, dumb than it seems. Yeah, I know this sounds a tad bit silly, but hear me out. Vomiting in space is actually kinda deadly, and horrifying, to say the least. Allow me to explain. The spacesuit helmets, they're sealed, yeah? Fully airtight. I mean, that's kinda the whole point. It keeps the vacuum of space from turning your lungs into, well, whatever I just explained in the previous segment. But It also means when your stomach decides to reverse course, that partially digested breakfast burrito has nowhere to go except back at ya. I'll get to why I said when instead of if in just a sec. On Earth, there's gravity to pull vomit down into the toilet or onto the floor or on your favorite shirt or mom's favorite rug or whatever. Just away from your breathing holes. But in space? Yep, zero gravity, so your vomit just floats right there in front of your face. A hovering cloud of stomach acid spinning lazily in microgravity, waiting to reintroduce itself into your respiratory system. You can't take the helmet off, obviously, because then you'd get to experience what happens when human tissue meets the vacuum of space. And as you know, it's not a good time. You can't wipe it away either. Your gloves are too bulky, and that floating bile, it's now coating the inside of your visor, blocking your vision, so you can't find your way to some pressurized chamber of the spacecraft either. So it starts filling your nostrils and creeping into your mouth every time you try to breathe. So, now you're drowning in your own partially digested food while floating 250 miles above the planet where drowning is supposed to require water. But wait, there's more. That vomit, it's acidic, and your helmet's ventilation system, the thing that's supposed to keep you breathing, is now sucking chunks of your acidic lunch directly into the oxygen circulation. The filters clog, airflow drops, carbon dioxide builds up. You're now suffocating and drowning simultaneously. Multitasking, am I right? A Soviet cosmonaut almost experienced this in 1965 during a spacewalk. He started feeling nauseous and knew that if he vomited, he'd choke to death in his own helmet. So he just swallowed it, forced it back down, spent the rest of the walk trying his best to continue existing while his body kept asking, "Hey, can we revisit that whole vomiting thing?" Space motion sickness hits about 60% of astronauts, and it's pretty common and natural actually, because your inner ear, the thing that tells your brain which way is up, stops working when there is no up. So in space, it's not really if you get nauseous, it's more like when, because your brain gets confused signals due to the lack of gravity and hence direction, panics, and decides the solution is evacuating your stomach contents, because apparently that's how human biology troubleshoots existential confusion about orientation. The body's answer to "where am I" is "let's vomit about it." Humans spent millions of years evolving on a planet with gravity, then built a suit that traps them inside their own biological malfunctions. We haven't conquered space just yet, but we sure as hell have found new ways to drown. Ever wonder what your dinner feels like from the inside while being microwaved? Me neither. Not until now, at least. And now that I've said it, I bet you're wondering it too. And, well, space can show you. See, the sun doesn't just provide light for the flowers to bloom and warmth and all that wholesome stuff we learned about in the 3rd grade. It's also constantly blasting out radiation, like a lot of it, the kind that turns living tissue into something you'd scrape off a grill. On Earth, we've got this nice little thing called the atmosphere that filters out most of the nastier stuff. Acts like sunscreen for the entire planet by blocking off radiation that would otherwise turn your morning jog into a medical emergency. In space, yep, no atmosphere, just organic matter meeting unfiltered cosmic radiation. That is, if you're not wearing your spacesuit. It's always the damn spacesuit, isn't it? Which is why it's so baffling that our old mates from the first case decided not to take it along with them. But anyway, the point being, your spacesuit protects you from a lot of stuff, obviously, and radiation is one of them. It's got layers specifically designed to reflect and absorb that radiation. But here's the thing about protection. It only works when it's, intact. A tear in the suit, a malfunction in the shielding, even just being in the wrong spot during a solar flare, and congratulations, you're now experiencing what it's like to be a rotisserie chicken, except you're still aware of it. The sun doesn't cook you evenly, by the way. That'd be too considerate. One side of your body, the side facing the sun, starts heating up. We're talking 250 degrees Fahrenheit, the temperature where water boils and skin starts breaking down. The other side, negative 250 degrees, because space has no air to hold heat. So the side in shadow just freezes. So you're simultaneously cooking and freezing. Multitasking, am I right? A solar flare makes it worse. The sun occasionally has these little temper tantrums where it hurls out massive bursts of radiation in enormous eruptions. All stars do, actually, and they're so powerful that one hitting the Earth would directly result in my worst fear, the death of all electronic devices and the internet. And yeah, by the way, it would result in our deaths too. Well then, why hasn't it happened for hundreds of thousands of years, you might ask? Actually, it has. But we've got this nice thing called the atmosphere that filters it out. Although, if you're caught outside during one of these solar flares without proper shielding, you're absorbing radiation levels that start killing cells faster than your body can replace them. Your DNA just starts falling apart. Not, you'll get cancer in 20 years falling apart. More like, your insides stop functioning in hours falling apart. We have built machines that can survive the vacuum, the cold, the radiation. We built suits that can protect us for a few hours at a time, but we're still just squishy biological things that evolved in a very specific environment with very specific protections. We didn't adapt to space. We just figured out how to visit briefly while wrapped in increasingly complicated layers, hoping nothing tears. One malfunction away from discovering what the inside of a microwave sees. Humans spent billions of years protected by an atmosphere we didn't even know existed. Then we left it and realized exactly what it was protecting us from. You know those cheap folding lawn chairs that just give up when someone sits on them? Now imagine that happening to your spine. Re-entry into Earth is supposed to be the easy part, right? You've already survived the launch, the vacuum, the radiation, and of course, the vomit. Now you just point the capsule at Earth, hit the atmosphere, slow down, land, do a press conference, maybe a few pictures, and sign an autograph or two before being reunited with your family that hasn't seen you in months. Simple. Except the angle has to be perfect. And I mean perfect. Too shallow and you skip off the atmosphere like a stone on water, float back into space, and run out of oxygen while your capsule becomes a very expensive coffin. Too steep? The atmosphere doesn't slow you down gently. It grabs you and slams you into your seat so hard, your skeleton tries to exit through your back. But before I explain the how and why, let's talk G-forces real quick. G is just how heavy gravity makes you feel. 1 G is normal. You, right now, existing, watching me at whatever ungodly hour this is. 5G means everything suddenly weighs 5 times more. Your 80-kilo body now feels like 400 kilos pressing down on itself. 10G, your chest is a car parked on you while you're still trying to breathe under it. Now put that inside of a metal capsule slamming into thick air at the wrong angle. The ship decelerates too fast, but your body doesn't. Your spine compresses. The discs between your vertebrae squish like those squishy stress toys, except they don't bounce back. Vertebrae shove into each other, and the straps keeping you strapped in start cutting into your shoulders and hips, trying their best to section you into neat pieces. Your ribs bend inward. Some snap and start pointing at your lungs and heart like tiny spears. And your brain. Yeah, that's just a soft lump floating in fluid inside your skull. It's not actually fully attached to it like one might believe. When the capsule eventually slows down, your skull stops instantly. But your brain doesn't get the memo. it slams into the inside of your head, similarly to how you would slam into the front of a car if someone suddenly pulls the brake while driving well over the speed limit. Tiny blood vessels stretch, then tear. The brain bounces back, then forward again. High G's for long enough, and the rest of your brain literally fully detaches from the inside of your skull. Or, in simple terms, the cable that attaches your brain to your spinal cord, called the brainstem, is no longer attached. That's like unplugging the CPU from the computer. If the capsule starts tumbling, congratulations! It gets worse. Your upper body wants to go one way, your legs another. The seat keeps your hips locked while your torso keeps moving. Your spine becomes a hinge it was never designed to be. Ligaments rip. The thing that's supposed to keep you upright folds you into a human V-shape. Here's why this happens. Space travel is just math trying to keep biology alive. Every calculation has to be perfect. Angle, speed, fuel, weight. You shave off safety margins to save mass. You trust computers and checklists and strap a squishy animal body into a machine rising a razor-thin line between controlled descent and high-speed biology demonstration. Once you hit that atmosphere, there's no undo button. If the math is off by a degree, your skeleton pays the bill.